Good morning, everyone. Can you all hear me? And can you see the screen? Okay. So yesterday we have studied about the equations of kinematics, and now we are going to solve problems related to that. So we were solving that question. Uh, Solving this question, the example, this one. Okay. Right. So I think we finished it, didn't we? We finished it, right? No, direction is remaining. We still have to talk about direction, right? Okay. So for direction, as I did mention earlier, if you want to find direction of a vector, and you can do that by taking tan theta equal to Vy by Vx, right? So if tan theta is equal to Vy by Vx, then let's put the values. So Vy, y component is 4t and x component is 3. And we have to do it at time t equal to 1 second. So at t equal to 1 second, tan theta will be equal to 4 by 3, right? Tan theta will be equal to 4 by 3, right? So that means, sir, wait, students are coming. Why should I wait for you? You are here. Study it. That's it. So tan theta is Vy by Vx. That is equal to 4t by 3, right? And we put t is equal to 1. So we get tan theta is 4 upon 3, right? So now, based on that, we have got the answer. So it makes an angle theta, right? It makes an angle theta. This velocity makes angle theta with positive x-axis, such that tan theta is equal to 4 by 3, right? Okay. Yes, good morning, everyone. So you have chemistry class early in the morning. All right. What's the time? 7 to 8. Okay. Fine. All right. No problem. Don't worry. We haven't covered a lot. Okay. We just started 2 minutes ago, right? what you are seeing here in green is what we have done, right? Okay. Yeah. So to find any vector's angle with x-axis, I hope you remember that property, right? We can draw a triangle like this and call this theta. So tan theta is going to be Vy upon Vx. Okay. And we have just put these values. What is the value of Vy? It is 40. And what's the value of Vx? It is 3. So I've just put those two values here and we get 40 by 3. All right. Okay. And then we put t equal to 1. So that's it, right? So this is what we have done so far, right? We have got that tan theta is 4 by 3. Now tan theta is 4 by 3, or you could write theta is equal to 53 degree also, right? I hope you remember that I told you to remember tan 53 degrees value is 4 by 3, right? Okay, clear everyone? Those who came a little bit late, is that okay? All right, right. Now we're going to solve exercise question. No, let's solve one more example. I think the next example, this was 3.4 if I'm not wrong. The next example can also be done, right? Let's do that. Your chemistry classes have started today, is it? Okay, right. All right. 104. Fourth chapter, right? Yes, 104. Which chapters could be there? I think you have been informed. Have you not been informed about about the exam chapters? Okay, right. They will give it to you in a day or two. Most probably it will be 2, 3, and 4, right? Most probably it will be 2, 3, and 4. Okay, right. Now, so here is the next question that we are going to solve. Example 4.5, right? So it says that a particle starts from origin. Okay, so what is the initial position? It is 0 I caret and 0 j caret. Okay, I hope that is clear. Initial position, right? Yes, 0 comma 0. If you want, you can also write this as 0 comma 0. Now with a velocity 5 I caret meter per second. So that is the initial velocity v0 vector. See, it's given in vector form, 5.0 or 5 I caret, and obviously nothing is given for j caret, so 0 j caret meter per second. Okay. Okay. And moves in xy plane under the action of a force. Okay, all this you can ignore, right? There is some force acting on it, and I'm sure you all know that whenever there is a force acting, there is going to be a acceleration, right? Possible. So now there is a constant acceleration of the body, that's this much, right? So let's write that here. A vector is equal to 3 I caret plus 2 j caret, and in meter per second square, of course, right? So this is what we know. Now, what is the y coordinate? What is the y coordinate of the particle? So the first question says, what is y coordinate? Okay, at the instant means at the time. At the time when its x coordinate is 84 meter. I hope this question is clear, right? We have to find what is y coordinate when x is 84. So you see here, the diagram is not very important, but I'd still draw it, okay, so that you get a feel of what is going on, right? So let's say that this is origin, right? The particle starts from here, right? Particle starts from here, and then this particle is now going to move, right? It has some initial velocity, and it has some constant acceleration, so it's going to move. So let's say it moves like this, right? I'm just drawing it randomly, okay, don't go by the shape, right? And it reaches here. Now at this point its x coordinate is 84, but we don't know what is the y coordinate, and we have to find this y. Is this clear? Right? So it goes from 0 0 to 84 comma y, and we don't know what's the y coordinate. We have to find it, right? Now I tell you one thing. If you look at this whole situation, we are not given time, correct? We are not given final velocity, right? We don't know what's the final velocity vector also. So you see, it's not possible to use any of the equation. આ નથી ખબર એટલે સેકન્ડ તો ન થાય, આ નથી ખબર એટલે થર્ડ એ ન થાય. તો ફર્સ્ટ થી તો કોઈ દિવસ પોઝિશન કે ડિસ્પ્લેસમેન્ટ કે એવું કંઈ મળી જ ન શકે, રાઈટ? I hope you understand what I'm saying, right? So what we have to do is we will have to find time first. We will have to find time first, right? So what do I mean? See, we are given everything about x. We're given everything about x. So from that we can find out time. From that, no, there is no need of integration, right? Okay, this is a simple question only, right? So we from x components we will find out time, and once we get time we can get the answer, right? So let's start. Okay, so here for p to q, all right, or o to q, actually o to q, origin, બરાબર ને? origin છે ને o, right? For o to q, right? So I'm going to use the equations of kinematics for x only. I hope you remember yesterday I taught you that you can do it separately for x and y. So we'll do it for x because we know everything about x. We know everything about x, right? So we will use the second equation, because we want to find out time. So delta x is equal to v0 x t half ax t square. Do you still remember the meanings of all these symbols, people? Do you still remember the meanings of all these symbols? ગઈકાલે પ્રેક્ટિસ કરાવી હતી. એવરીવન રિમેમ્બર્સ ઇટ? ઓકે, તો હવે વેલ્યુઝ મૂકવાનો ટાઈમ આવી ગયો છે, રાઈટ? So look at this diagram. Look at this diagram. Tell me what is delta x. Tell me what is delta x. Delta x means change in x. Don't forget that. Or displacement in x direction or x component. X component of displacement. Yes, very good, Falak. Yes, well done, people. I'm getting all right answers. Very good. It is 84 is equal to. Now let's go back to the question. We want to write v0x. Okay, I hope you all are making, I mean you are writing something in your notebooks, right? What is v0x? What is v0x? What is v0x? ના, હજી આમાં તકલીફ પડે છે. હા, તો એની વેલ્યુ શું છે અમી? What is the value of x component of initial velocity? X component of initial velocity. It is 5. Yes, it is 5. જો ને અહીંયા લખ્યું છે 5i caret plus 0j caret. So this is v0x, correct? I'm sure all of you understand that, right? And this is v0y, right? So let's put the value here. 5. T we don't know, otherwise why would we be doing all this? Half. What is ax? What is ax? Easy to do. What is ax? What should I write instead of ax? હવે બધાને આવડવા માંડ્યું, બરાબર છે. 3. Very good, very good. 3. ચલો, thank you. Let's write 3 here. And now you have 1 minute to solve this equation. Hurry up. આ જાતે કરવાનું સોલ્વ. આવડે ને સોલ્વ કરતા? કરો કરો ચલો. Hurry up, come on. મેં કેમ તમને આપી દીધું? કારણ કે મને તો મેથ્સ આવડતું જ નથી આવું બધું. સો આઈ ગીવ ઇટ ટુ માય સ્ટુડન્ટ્સ. એ કરી લેશે બધા. I've not got anybody's answer yet. Root 21. Okay. હવે ખતરનાક આન્સર આવ્યો. Clearly it's not going to work. It's not right. તો સોલ્વ કરો એને. નથી થતી. અરે 2 મિનિટ થઈ ગઈ, ક્યાં છો બધા? What happened, people? What happened? Is there some problem? 6. Okay. Well, let me do it then. તમે તો બહુ વાર લગાડ્યો. I took LCM and multiplied 2 everywhere. So now I'm going to simplify it. 3 square plus 10t minus 168 is equal to 0. Right? Now here you have to do factors of it, 3 into 168. Okay, 3 into 168 is going to be, well, you take an 8 out here, so this is 24 and 2 1. Okay, 10 જોઈએ છે ને આપણે, so this doesn't work, right? So instead of that you take a 7 out here, so okay, તોય નહીં થાય. 24 into 21. Okay, we want a difference of 10. જોરદાર ફેક્ટર છે આના તો. So if you can't find the factors, then all you have to do is the quadratic formula agree. Discriminant method થી કરી નાખવાનું. જો factors ન મળતા હોય તો એવું કરી નાખાય, right? So I'm just going to do that very quickly here. We have t will be equal to minus 10 plus or minus root b square minus 4ac એટલે 12 into 168. ઓહ, આ તો બહુ મોટું છે. આના કરતા તો ફેક્ટર્સ જ સારા હતા. Okay. So from here you can take a 4 out, right? So 3 into 168 is finally 4 and carry 1 9 20 0 carry 2 504. તો આવું વિચિત્ર આવે છે બહુ. We're getting 504. I think I've made a mistake somewhere. 28 and 18 are factors. Okay. I took a 4 out. B square minus 4 AC. એટલે તો બરાબર થયું. $23, yeah. Okay, yes, that's right. So this is what we are getting, right? So that is minus 10 plus or minus 46 by 6. So either it is 36 by 6 or it is minus 56 by 6. This is not possible because that is in past. So the correct answer is 6 seconds. આવી રીતે થશે. Okay, otherwise like Dikshita suggested, factors are 28 and 18. Okay, factors are 28 and 18, right? You could do that as well, right? Okay, never mind, let's not get off the track. So t is 6 seconds એટલું મળી ગયું. Okay, so what we have found is going from O to Q, it takes 6 seconds time interval. All right, it takes 6 seconds. So now we have to find what is y. We have to find what is y based on t equal to 6. So we should use which equation now? If you want to find y, we should use which equation? Come on, people. We should use which equation? Yes, the second equation will help because we know the time now, right? I hope you understand. We know the time. So the second equation will help. So we'll use the second equation, right? So for O to Q once again. But this time we want to find y. So we have to use delta y. Okay. This time we want to find y. So we'll use delta y. So delta y is equal to V0 yt plus half ay t square. Okay. Let's put values. What is V0y? Go back to the question. V0y. What's V0y? 0. Very good. Very good. It is 0, right? And ay is 2. right? V0y is 0 and Ay is 2. So let's put values here. Clear? So that's it. We have got delta y is 36 meters. See, this is not y, mind well. This is delta y. Okay. We have to find the y coordinate. So delta y means final y, which is y, minus initial y. What is initial y? What is initial y? What is initial y coordinate? What is initial y coordinate? Yes, it is 0 because it is given that the particle starts at origin. Okay. So that's your final answer, right? So you could just put that in one final sentence. When particle has x equal to 84, y is equal to 36 meter. Can we write 36 j caret? No, you cannot. You cannot, because here we are not writing anything in vector form. Have a look at all this. We are writing all of these in component form. Okay, so here you should not really specify j caret. Okay, it is understood that this will be j caret only, right? Yeah, he is also saying yes, right? Okay, so that's how you solve this question. I think there is a part B also. Let's do that. So what is the speed of particle at this time? So that's the question. That is when t is equal to 6 seconds, right? What is speed? Speed has this symbol. I'm sure all of you remember that. Okay, this is speed. V for speed, V vector for velocity. So how do you find speed, people? How do you find speed? How do you find speed? No, Vedant, dx by dt is not speed. Kavya, that is velocity. Yes, we have to find magnitude of velocity. I hope everyone understands this is what we have to do, right? I hope everyone understands. We have to find magnitude of velocity, that is under root vx square plus vy square, right? Okay, so for that we have to find what is vx and what is vy. Let's do that. So for finding vx, we can use first equation of kinematics. Vx, again this is for O to Q, remember all of this is for O to Q. For Vx is equal to V0x plus AXT. Put the values, tell me this final answer. And similarly for O to Q, once again you find Vy on your own. Come on, I'm giving you 1 minute here again, make it fast. But Vandan, now we have t's value, right? You could put t's value if you want. Okay, very good, Falak. Well done, Jaikit. Yes, Kavya, that's right. Yes, Princey, Priyansh, correct. Ami, Yeah, 23. Yes, that's right. Okay, so I think overall people have done it, that this is 23 and this is 12, right? This is 23 and this is 12. So let's put the values here. So we get speed. Okay, bus એટલું જ કરવાનું. એટલે next step, just put these values. Therefore, v is equal to under root vx square plus by square is equal to under root 23 square plus 12 square. 23 square is 529, 12 square is 144. So this is going to be 3 and 7 and 6. 673. Okay, I don't think this is a perfect square. We'll have to take square root. It's very close to 676, isn't it? I think you all get that. It's very close to 676. So it's going to be nearly 26, right? Nearly 26, not exactly 26, right? It's going to be this. Okay. In fact, કેટલું ઓછું આવશે? It is going to be 26 into 1 minus 3 ઓછું છે ને? 3 by 676 into 2. This is what it's likely to be. Okay, this is what we'll get. થોડુંક ઓછું આવે 26 કરતા. Right. Okay, anyways, so that's it, right? Now there is a question like this in exercise. Okay, you are going to get a lot of homework today, right? I'm going to mark out those questions and you have to do it for homework. Okay, right? So we go to the exercise. There's a lot that I have to give you. Okay, so I'll just do one thing here. Okay, let me make a list. Anyways, let me make a list. Can you still see the screen? Can you see it? Okay, very good. So 4.8 is homework. આ બધું homework જ છે. Okay, exercise question 4.8. Everything is from exercise. Okay, 4.8, right? Okay, 4.9, 4.10, 4.11. Question વાંચતો જાઉં છું, homework આપતો જાઉં છું. No, the link for this will not be sent. Okay, right? You'll have to do it. That's it, right? So these are the 6 questions for homework, right? હજી તો બીજાય છે, ચિંતા ન કરતા. Okay, now one more thing. In this question, if you look at 4.9, yeah, you can send it to me, no problem. Okay, because the school might not send you the link. So you can, if you do it and you want to verify it whether you have done it right or not, you can send it to me, no problem. Okay, So in 4.9, it's not clear whether the person is moving on the circle clockwise or anti-clockwise. Okay, if you'll have a look at 4.9, you'll understand what I'm saying, right? So I think let's take it clockwise. Okay, everyone just remember where the question 4.9 is, you please write clockwise. That is the person goes from P to Q clockwise. All right, I don't know what's the answer given at the back. Okay, I don't care about that. Question બે રીતે સાચો થાય, આ લોકોએ કંઈ લખ્યું નથી, so we cannot know. All right, so everyone, where this 4.9 is, you just write clockwise next to it, and I'm sure you will understand, right? પછી આન્સર મેચ ન થાય તો કંઈ વાંધો નહીં, you can confirm it with me if whether it matches or not, right? આટલું હોમવર્ક આપ્યું તો બે જણ ઓછા થઈ ગયા. Only direction will be different, magnitude will be same. For magnitude of displacement it will be same, બાકી બધું ચેન્જ થઈ જશે, right? Okay, so I think that's enough about this part, right? So we are done with it, right? Now the next thing according to the textbook is relative velocity, but like I said, we are going to do it at the end. Okay, relative velocity બધું છે ને એન્ડમાં જ રાખો, એન્ડમાં એટલે આ ચેપ્ટર પૂરો થાય ત્યારે, લાસ્ટ ટોપિક. Okay, it has no connection with anything else in this chapter, right? It has no connection with anything else. Okay, now so that's done. Now we are on to projectile motion, right? We are on to projectile motion. What is net displacement? Net displacement એટલે displacement, Rahul. Okay, total from all the way from start to finish, right? Net એટલે total. English થોડું આવડતું જ હશે, એટલું તો net તો ખબર પડે. Okay, so now we are on to projectile motion, which I find very nice, very interesting personally, right? Okay, so what is, first of all, once again, I think I may have told it earlier, but projectile, project means to throw. Actually the word project means to throw, right? Okay, that actually reminds me that there are so many such words in English language, isn't it? Right? Object, subject, reject, all these words are actually coming from coming from the same you know, same origin, right? So originally in Latin, reject means throw backwards, subject means throw downwards, right? And object means anything that you are throwing, right? Okay, object is the thing that is thrown or what is thrown, that is called object, right? Okay, but now of course the meanings have changed, right, over many centuries. Now we are using it for totally different thing. Now if someone is going to say project, then you are not going to say throw, right? સ્કૂલમાં બહુ પ્રોજેક્ટ કર્યા હતા. Okay, but actually the word project means to throw, right? એક બીજો word છે આને related, trajectory. I think you would have heard this word, trajectory. Right? Trajectory means the path on which this thrown object moves, right? Trajectory is the path on which this thrown object moves. Nevertheless, આપણે ઇંગ્લિશ નથી શીખવાનું, આપણે ફિઝિક્સ શીખવાનું છે. So let's come back to that. આ તો મને અત્યારે યાદ આવ્યું અચાનક, એટલે મેં તમને કહી દીધું. Okay. So projectile motion. So projectile means what you are throwing. જેમ કે let's say you take a stone in your hand and you throw it, you take a ball in your hand, you throw it. That's called projectile. Okay, and its motion is called projectile motion. Now typically you would see that, let's say you stand at some place, let's call that place origin, right? Let's say you stand at some place, okay, and you throw something, or let's say there's a football and you kick it, so ये आम जैसे. Agreed? I'm sure you understand this. Even a football will follow projectile motion, right? Okay, so typically here on earth we see that when we throw something like this at an angle, see, at an angle, if you throw it straight up, it would go like this and fall back, right? That was in chapter 3, right? We have already talked about such things. We have calculated how much time it takes and all that, right? Here also we are going to do similar things, but at an angle, right? That's the difference, at an angle, right? Now there are some basic assumptions that we must understand before we start. First one, as usual, we neglect air resistance. Again, why do we do this? So that the calculations remain within high school level. Okay, right? So that calculations remain within high school level, so we keep it simple. Basically air resistance is a slightly complicated. સ્કૂલમાં તે આ જ પ્રોબ્લેમ છે. સ્કૂલમાં આ જ પ્રોબ્લેમ છે, વ્હીકલ્સ નીકળે એટલે એવો જોરદાર અવાજ આવે. I have the same. So if you want to keep calculation simple, we have to neglect air resistance. So you might say, wouldn't it be wrong if we ignore something? It has some effect, right? I'm sure you realize air resistance definitely has some effect. But if we ignore it, if we neglect it, then whatever we are doing is wrong. Many people have that idea, right? Many people have the idea that if we are neglecting something, it means we are doing it wrong. ઘણા તો એમ જ કે સર તમે તો ફિઝિક્સમાં બધું નિગ્લેક્ટ જ કરાવો, તો આ કંઈ સાચું જ નથી. Yes, the thing is, whenever we neglect something, we create, or whatever answer we are getting, that will definitely have an error. But as long as the error is small, we are happy with it. Okay, as long as error is small, we don't mind, right? Okay, પછી એવું ન થાય કે error બહુ વધુ હોય. Let me give you, okay, let me write one more thing. We neglect effect of wind. I hope you understand that. We neglect effect of wind. Right? Now, see, think about this. Let's say you take a piece of paper, this is a piece of paper, and you crush it and make it like a ball and you throw it. Right? If you throw it, then definitely wind will have effect on this, right? on this piece of paper when you try to throw it, અરે તમે બેડમિન્ટન તો રમો છો ને, I'm sure you realize, yes, air drag and air resistance are same thing. Okay, so if there is going to be wind, then it's going to fly here and there, right? So even if you throw it like this, it's possible that because of the wind it goes off like this and comes back. Fine, I'm sure you realize this, right? So what in such cases, neglecting wind will give you big error, right? Because if the wind is very strong, okay, there is a lot of you know, the air is moving a lot, in such a case it's not going to be possible to apply it for a piece of paper. But suppose you take a stone, right? Suppose you take a stone, right? Then for a stone, more or less the wind does not have a lot of effect. Do you agree with me? If you take a stone, then the wind does not have a lot of effect on it, right? Okay, so this is the advantage of neglecting things. And we should understand that we are trying to play safe here. We only do it such that the error is small. If the error is big, we will reject it. We will say that okay, this kind of analysis or calculation is not valid, right? Okay, so let's continue. There is one more there are actually two more assumptions, bahut khatarnak hai. Number 3, it's that the object does not go very high, right? So that we can say that G is same, that is constant. See, I think you would have studied this in 9th. I'm not so sure though, I'm guessing actually. Pella to avtu tu. Okay. Earlier in 9th standard, you might have studied this, that as you go high above the earth, the value of G will decrease. Are you aware of this? That here it is 9.8, but if you go a little bit, I mean quite high, it's going to be like 9.1 and 9 and all that. Do you know that, people? Okay, so right, so it's that we, whatever object we are throwing does not go very high. So કેટલું high જઈ શકે? 100 meter no problem, 200 meter no problem, 1 kilometer still not a problem. પછી એવું નહીં કે સેટેલાઇટ જેવું લોન્ચ કર્યું છે, ઓકે, that goes very high. So for things that we typically throw by hand, or things like, you know, small or big cannonballs, right, which don't go very high, this is okay, no problem, right? But not like satellites. Fine, not like big rockets or big satellites. Okay, I hope that is clear. Now the fourth assumption. Fourth, okay, the object does not go very far. The object does not go very far. That is, we can consider that Earth is flat, nearly, that is, okay. Right, because you see, let me draw something very interesting here. I hope you realize that suppose you throw something from here and it's actually going very far, like thousands of kilometers, right? Suppose it's going thousands of kilometers, right? Then whatever you are throwing like this will actually curve and fall on earth like this. So you see, when it goes to a very large distance, and આવી વસ્તુને મિસાઇલ્સ કહેવાય, બાય ધ વે, પથ્થરો આટલો દૂર ન જાય તમારાથી, તમે ગમે એ કરો, right? So it is that if something goes very far, you can clearly see that this earth is curved, right? So it has an effect. But if you take a stone in your hand, let's say this is a big football ground or something, okay, that's you. You take a stone in your hand, little stone, pebble, and you throw it. So do you think by where it falls in that much distance, the earth is going to curve a lot? Arm thai jai earth. I hope you understand what I'm saying. Does the earth curve that much? You can stand on a flat on a tall building, right? You are still going to see that earth is nearly flat. I hope you understand that earth is nearly flat, right? I know it's not flat. I'm not saying that earth is flat. એવું પાછા કહેતા નહીં કે સરે શીખવાડ્યું હતું earth is flat, right? Earth is definitely sphere, but or spherical. But if you throw a stone, બહુ બહુ તો કેટલો દૂર જશે? You cannot throw it even 100 meter far, right? I'm sure you understand what I'm saying. 100 meter એ ન જાય. So in 100 meter, the earth is not going to go. હા, મને ખબર જ હતી ફલક, તું બોલીશ એવું. So in 100 meter, you could consider that the earth is nearly flat. So this is the fourth assumption. Okay? આ બધું દર વખતે અઝ્યુમ કરી જ લેવાનું, કોઈ કહેવા નહીં આવે. અહીંયા મેં ટ્રિપલ એન કરી નાખ્યો, બોલો. એન લખતા લખતા. Okay, so please make sure you understand these assumptions. All right? Right? So with these assumptions, let's start. પહેલા ખાલી ટર્મ્સ શીખવાડી દો. ઓકે, એક મસ્ત ડાયાગ્રામ ડ્રો કરીએ. Right now we are talking about some object which is thrown from ground or very close to ground. Okay, so it goes off like this, right? Okay, so its initial velocity is like this, v0 vector, initial velocity. કેમ આવી રીતે આવ્યું? એક સેન્ટેન્સ હતો, velocity is in direction tangent to the path. યાદ છે ને? Okay, so I hope you realize this is the initial velocity. It is tangent to the path. Okay, and let's say that we are throwing it at an angle theta 0. Okay, okay, can you all hear me? Is my voice clear, everyone? Can you hear me, everyone? Hello. Can you hear me, everyone? Can you all hear me now? Okay. Right, let's continue. So, oh, right. So, this is the initial velocity, right? So, let's write all the terms. Initial speed v0, initial velocity is v0 vector. Okay, angle of projection, angle of projection means at what angle you are throwing. Okay, that is initial angle. Okay, the initial angle, that's how much, theta 0, right? Okay, these three things clear, all of you? Oh, okay. I'm actually waiting for all of you to say yes or no. Because I don't even know whether my connection is working.